Alright, I'm going to take you through at least a good bit of a couple of problems from the homework, just so that you can make sure that you kind of are checking that what you're doing makes sense. This one, pretty straightforward. We have a particle moving. It's moving on a straight line away from wherever it started. And so you have a function that gives you the distance in terms of the time, and you want to find the average velocity. So the tricky part about this is understanding what velocity means. Velocity is just speed in a certain direction. So in this case, the velocity would just be the speed at which they're traveling, at which the particle is moving. And so that's just going to be the rate of change, right? And so you want to find the rate of change between 1 and 3 seconds. So that's going to be the average rate of change between when t is 1 and when t is 3. So for part A, d of 3 minus d of 1 divided by 2. And 2 times 9 is 18, minus 3 is 15. And that's minus 2 minus 1, which is 1 over 2, which is going to be 7. And this is in feet per second. So Ft, you could write it as Ft like this, or you could write it as FPS. Either one, feet per second. All right. So in part B, we're finding an instantaneous velocity, and what this is really asking is what's the instantaneous slope or instantaneous rate of change when t is equal to 2 seconds. And so we're just going to take the limit as h approaches 0 of d of 2 plus h minus d of 2 over h. And here, you're going to plug in to your function here. So the limit as h approaches 0. And so 2 plus h. So this is where you got to make sure you're a little careful. Right, you're plugging into this function here. And so d of 2 plus h is going to be 2 times 2 plus h squared minus 2 plus h, okay? That's going to be d of 2 plus h. And then d of 2 is just the value you get when you plug in 2. So 2 squared is 4, times 2 is 8, minus 2 is 6. So minus 6 all over h. And now when you plug in, if you attempt a substitution, you'll get 0 over 0, and that's not good. So what you want to do is work with some manipulation to cancel an h and an h so that you can then use substitution. So go ahead and fiddle with the numerator and you should be able to make it happen. Alright, this is part C of, I believe, question 3. And so what we want to do is we want to find the instantaneous rate of change when t is equal to a. And that might sound weird at first, right? What does that even mean? Well, this means that you're finding the instantaneous rate of change for any time that you want, basically, right? You can say, well, hey, once I've found this, I can just plug in whatever value for a I want, and I'll know the instantaneous rate of change at that point in time. So it might be helpful to write it out first. Limit as h approaches 0. So what we want is f of a, right? We're finding the instantaneous rate of change when t is equal to a plus h minus f of a over h, okay? All right, so remember, when we're finished with this, we're going to have some value of a somewhere or other, and that's going to allow us to then plug in any time we want and figure out the instantaneous rate of change. So if I continue on here, I'll have the limit as h approaches 0, and a plus h, so this is going to be 1 over a plus h minus 1 over a divided by h. Okay, So if you plug in 0, notice that you're going to end up with 0 over 0. So we're going to want to do some sort of algebraic manipulation so that we can get some h out here. And so I encourage you to remember what will we do if we have the variable in the denominator of our numerator, so to speak. We have a rational inside of a rational. What we can do is we can multiply by the denominator here. Okay? So I encourage you to go ahead and try that out now on your own and see what you end up with. Okay, so notice what I did is I multiplied by a times a plus h in both the numerator and denominator. Now you could have just as easily just multiplied by a plus h in both numerator and denominator, and you would have still been able to wind up just fine. So I encourage you to do that as well as if you want to try it out. But this way, I'm getting rid of both denominators. So a plus h over a plus h will cancel, and then here a over a will cancel. So I'll end up with a minus a plus h in the numerator. You can already see how that's going to work out perfectly. And then the denominator, I'm going to have h times a plus h. Remember, my problem was that when I plugged in 0, I ended up with 0 over 0. So I'm looking to cancel an h and an h. Well, I have my h down here. What about up here? Well, if I distribute my negative, this is going to end up being minus a minus h. And so now I can cancel the a values here. A minus a is 0. And so I can rewrite my limit as h approaches 0 of negative h, my numerator, times h times a plus h. And h over h is going to be 1 over 1. And the reason that is, we can cancel those h's because the limit is as h approaches 0, not when h is equal to 0. So this will always be 1 over 1 so long as I don't have an h value of 0, and I won't because I'm approaching, not at. And so now I have negative 1 in my numerator, and then in the denominator I have a times a plus h. And so now I can substitute in 0, and this is just going to give me a plus 0, which is a. So I'll have a times a, which is a squared. So my limit as h approaches 0 is going to be negative 1 over a squared. Okay, and you're wondering, what is this? Well, this is the instantaneous rate of change whenever your time, the time that you are looking at, is equal to a. And so if you're saying to yourself, okay, well, I wonder, what would the instantaneous rate of change be at a time of 0.5? Well, plug in 0.5. This is finding the general function for the instantaneous rate of change whenever you have a time of a. And we're actually going to be, it's kind of a precursor for what we're going to be spending a lot of time on. And part 2 says, at what time will the instantaneous rate of change be negative 1/4? Well, this is the instantaneous rate of change when your time is a. So if you set negative 1 over a squared equal to negative 1/4, then you can solve for the time that you're looking for, a. Okay? How can you do that? Well, you can multiply by a negative on both sides to turn this into positives. So you have positive, positive. And then you can take the reciprocal. So you can take the reciprocal of both sides. You'll have a squared equals 4. And then you could square root both sides. And you'll have a equals, now this should be plus or minus, so it should be plus or minus 2, but we're using time here. This is time, so we only like to think of positive time, so when a is equal to 2 seconds. So 2 seconds into your journey, your instantaneous rate of change will be negative 1/4, and you could try that, right? Plug in 2 here, 1 over 2 squared, 1 over 4, negative 1/4. All right, I wanted to quickly discuss this one. The AP likes to do this a lot, College Board likes to do this a lot. They like to give you a geometric shape and ask you a question about how it's changing, which is kind of weird to think about because usually we think of shapes as being static and not moving at all. And really what they want you to do is they want to see, do you really understand what finding the instantaneous rate of change means? And really what you're doing is just looking at a function and taking a limit of the difference between the function at different points as the difference between those 2 points gets to 0. So what we need to do here is keep in mind that the area of a circle depends on the radius and is equal to pi r squared. So if you want to find the instantaneous rate of change when r is 3, what you're really finding is the limit as h approaches 0. And the radius is 3 here, so what you're looking at is a of 3 plus h minus a of 3 over h. And now you can plug this in and just work from there, right? 3 plus h in here, 3 in here, and find your limit. And it's something that they throw at you a lot, so you'll want to be familiar when they say, what is the rate of change of the area of a circle? And you're like, what do you mean? Well, just keep in mind that the area of a circle is just a function, right? The area, which depends on the radius, is given by pi r squared. They'll do this with volume and, volume and area quite often. So go ahead and finish this out. You should see that you can find your answer quite easily.